Hi. So I'm going to show you some demonstrations of types of chemical reactions in case you weren't in class when we did this. What I want you to do is to take some observations of the starting materials, the reactants, and observe what happens throughout the course of the reactions. And then at the end, you're going to write some full molecular equations with correlations to your observations, and then a net ionic equation for each one of them. Okay? So we're going to start with, we'll need a little flame for this. I have some magnesium ribbon here. Magnesium metal. Looks like this. Sort of a grayish strip of metal. It's very flexible because it is a metal. So we're going to take this and I'm going to put it in the flame for just a second. Okay? And you'll make your observations of this. Okay? Pretty neat, huh? Now, I want to show you what it looks like now. So, if you look, it's now no longer a gray piece of metal. It's now this crumbly white solid stuff sitting in there. Okay? So that's magnesium metal being burned, and we know that when we burn something, that has some implications as to what's involved with that. Okay? I can do something else with a little piece of magnesium. So, same stuff, magnesium metal. And I'm going to use some hydrochloric acid. Okay? So I'm going to take a little bit of hydrochloric acid, HCl, right? And I'm going to put it into a test tube, and I want you to look and see what hydrochloric acid looks like. Okay? Remember, we say clear and colorless. Okay? Clear is that I can see through it, and colorless is that it has no color. And I'm going to take my little piece of magnesium metal and I'm going to drop it in. Okay? Can you hear the sound? Okay? We've got something going on in there. Now, I've got some bubbles being formed, and we know that bubbles are indicators of gas. Okay? What gas this is, you should be able to figure out what gas it is, but I can test for this gas. The gas that's being formed here should be hydrogen, right? And I can test for hydrogen because hydrogen is flammable. So to test for hydrogen, all I need is a little bit of fire. Did you hear that? That little pop. That's an indicator that there's hydrogen present. Okay, hydrogen is very flammable, so it pops when it gets around fire. So there's your second reaction. Magnesium plus hydrochloric acid. So, I have here a piece of copper wire. Okay, you see that? That's copper wire. Sort of, well, it's copper color, right? And I'm going to use this copper wire with another solution. And this solution is called silver nitrate. Silver nitrate solution. So I'll show you what that looks like before I do anything. Silver nitrate. Again, another clear, colorless solution. I'm going to put the copper wire into the silver nitrate. And I want you to see if you can notice any changes right away. Okay, did you see the change happen right away? Look at that. It doesn't look like the copper wire on top anymore, does it? Okay? It's got a very different look to it. Now this reaction takes a little bit of time. I'm going to show you what it looks like if you leave it for a little while. So here's one I did yesterday. Okay? You see, the copper wire is now coated with this grayish stuff. And if you look carefully, look at the color next to my white lab coat. Look at the color of the solution. It's not colorless anymore, is it? It's got kind of a bluish cast to it. Well, that tells you something about what's going on in this tube. So this is what that other tube is going to look like in, well, in a day or so. Okay? All right. The next one, I'm going to use two chemicals. The first one is lead 2 nitrate. Lead 2 nitrate. Okay? I'm going to put some in here. You can see this is a clear, colorless liquid. You know, most solutions in chemistry are clear, colorless liquids unless they involve a transition metal, because transition metals are the ones that give you good colors to them. So here we're going to put in a little bit of lead 2 nitrate, clear, colorless. And to this, I'm going to add some potassium iodide. Potassium iodide is also a clear, colorless solution. So potassium iodide added to lead. Now this one happens kind of fast, so you're going to want to watch carefully, okay? Boom. Right away. Okay? Look at that. There's your observations. That's a very different color. Look at what's going on around the top of that solution. Do you see that stuff stuck to the walls? All right? That's a solid. There's a solid compound formed. You can see some of it at the bottom of the tube. That solid eventually is going to settle out. It'll look like this. See, there it is all at the bottom. And the solution above it is colorless again, clear and colorless. That solid at the bottom we call a precipitate. Okay, and you should be able to tell what that one is based on whether or not you know how to do these reactions. So I'll show you another type of reaction like that. So for this reaction, we're going to use our silver nitrate again, and you remember what silver nitrate looked like. Clear, colorless solution. And to this, we're going to add a solution of ammonium chloride. Ammonium chloride is also clear and colorless. You'll see as I pour it in that it has no color to it. But watch what happens when it hits the silver nitrate in there. See? Right away, we get a change. Look at that. Now, if I mix it a little bit, I can get rid of this little section at the bottom that hasn't done anything. See that? There we go. And what do you see at the bottom? You see a precipitate. Okay? So all that white color in there, that's solid, and you can kind of see a little bit of it at the top there, clinging to the sides, and you can definitely see it gathering at the bottom. That will also settle out. And eventually it'll look like this. Okay, all of that down the bottom. That's your silver nitrate, or that's your precipitate. And then the solution above it is also clear and colorless. Now, decomposition reactions are a little tricky because a lot of them are unsafe to do or require a lot of energy. So I'm going to do a really easy one. This is just store-bought hydrogen peroxide. And hydrogen peroxide undergoes decomposition naturally. It's something that's going to happen the minute I put it into this test tube, but you're not going to see very much because it's slow. Okay? Hydrogen peroxide decomposes into water and oxygen. But because it's so slow, I can't really see anything happening in there. So I want to speed this decomposition up. I want to be able to see it in a time so I don't have to sit here for a while. Even if I sat here all day, I wouldn't really see anything because the products of this reaction are also colorless and clear. So water and oxygen, you can't really see those, right? But if I can speed it up enough so that I can see the oxygen being produced, that'd be cool. So the way I speed up a reaction is I need a catalyst. A catalyst is a chemical that speeds up a reaction but isn't consumed in the reaction. Okay? So the catalyst that I'm going to use for this reaction is called manganese 4 oxide, or sometimes it's called manganese dioxide, MnO2. MnO2 is a blackish powder, and I don't need very much of this blackish powder. Just a tiny little bit should do it. About that much of the powder should work. Now when I add this, it's going to speed up the decomposition, and you should be able to see the bubbles. You can see the bubbles forming. That's your oxygen gas. Okay? Now if I want to test to prove that that's oxygen, I have another test because I know that oxygen is also flammable. So if I take a glowing splint and I put it inside, the oxygen causes it to light up again. See? Oxygen will cause a glowing splint to relight because it's flammable. Now, it doesn't pop quite as much as the hydrogen does because it's not that flammable, but it does cause a wooden splint to relight. So that's how you test for oxygen. Eventually, all that sort of blackish color will settle to the bottom because it's just this black powder, MnO2. And I will have in that tube exactly as much MnO2 as I started with because it's a catalyst. It just speeds it up. It doesn't get used up. Okay? All right, I'm going to show you a couple more quick ones. These are combustion reactions that I'm going to show you. And I'm going to show you the difference between two different kinds of organic compounds being combusted. So the first one of these I'm going to show you is a liquid. It's not aqueous. It's a liquid called methanol. Okay? Methanol is an alcohol, but it's not the kind of alcohol that you're going to want to drink at all. Okay? Methanol can actually cause blindness and death if you drink it. And I'm just going to light it on fire, which is always fun. Now, if you can see this, I'll see if I can move it a little bit. The fire here is blue, and there's no smoke being produced by this burning methanol. And it's almost gone. It burns very quickly. Okay? So no color really to the flame and quick burning. We're going to contrast that with this. This is called hexane. And hexane has the formula C6H6. Methanol is CH3OH. Hexane is C6H6. I'm going to put a little bit down like I did before. Okay? Big difference in the flame. It's yellow, and if you can see against my shirt here, there's smoke. So different type of burning, even though they're both organic molecules. So, I've got one more to show you, but we have to go to the fume hood to do it, so we'll do that. So what you're seeing here is a mixture of two powders, powdered aluminum metal and powdered iodine. Aluminum metal is sort of silver or gray, and iodine is purple. And I've added just a couple drops of water to get things going. Once things start to react, it's very violent. We even get some fire. We get a lot of purple smoke. It gets very, very bright. And then pretty soon it's over. And what's left behind is something that looks very different from the two substances that I started with. So, very visible reaction. It's fun to watch, and even more fun to do. So good luck. Write your equations.